Let's solve one numerical problem with Bairstow method. Let's look at this problem. Here, the problem has asked us that solve this function which is given in the polynomial form, and it has told us to start with the initial values of u and v to be 1. Okay, so we have to prepare it uh, accordingly. So this is how we can set things up with the value of u as 1 and v as 1. We have taken the coefficients of the f of x and then did the calculation as per our knowledge, and then we have got this thing at the output of the first stage. These are the values of b0, b1, b2, b3, b4, and we would need to do the same thing with b, the coefficients of b, so that we get the values of c0, c1, c2, c3, c4. So we have done our part, which basically says that we have calculated these things. So now we need to put our values in this equation. If you look closely, here the value of n is 4. So we will complete this equation for the value of n to be 4. So that gives us this part of the equation. And we need to plug these values into this equation. In this table, I have sorted the values. We need B3, B4, C1, C2, C3, C4. So these are the values we have calculated. And if we plug it in here, this actually is the final equation here. Now we have to solve this equation that will give us del u and del v. So this is our prime focus. And after solving this thing, we get the values of del u as this, del v as this. So we are almost at the end of the first iteration. That means we started with the values of u and v to be 1. And after putting this value of del u and del v into our first assumption, we get our first iterated value of u1, that is 0.70.76087. And what happens to the v? This is the value of v. I mean, after the first iteration of v, the value of v becomes this. We also need to calculate the approximate error for both the case. The approximate error for u is this, and for v, it turns out to be something like this. So what is the takeaway from here? We need to keep repeating the calculation with new values of u and v. We started our calculation with the value of u and v to be 1. Now we have found new values of u and v. Then we have to run the same calculation again. And we have to keep repeating it till we reach to the point where the approximate error is less than the required amount. In our question, we will be said that run the iteration till the approximate error falls below 30%, 20%, 10%, 5%, and then we have to keep repeating our calculation. And once we have reached to the end point, we have found the final values of u and v. That means we can now form the quadratic equation, which is x squared minus ux minus v. And if we solve this quadratic equation, that will give us two roots of the given function f. So that is the basic idea of Bairstow method. If you look at how to solve a numerical problem, that is on the easier side, but the theoretical discussion was a bit complex. But you do not have to remember those because there won't be any question like prove this part of the theory. But all the discussion has been done to make you understand why we are doing this in this numerical problem solving and how this thing has come into existence. I hope it will now be clear to you how to solve problems if you are asked to solve using Bairstow methods. Thank you very much.